Good afternoon, everybody, and welcome to our video today where we will be talking about Organic Chemistry, Chapter 4, Analyzing Organic Reactions. So this is definitely an important chapter for the MCAT, so let's take a look. So we have some basic vocab here. So we have nucleophiles, okay, that are nucleus loving, which means they have a negative charge or lone pairs, right? So the nucleophiles are going to try to find a nucleus. Then we have electrophiles, which are electron loving, therefore they have a positive charge. And then we have a leaving group, for example, H2O. And when a leaving group leaves, the rest of the molecule is able to stabilize the additional charge that is taken on when that leaving group leaves through resonance. So those are just some important words to know. And we also have SN1 and SN2 reactions, which are definitely an important part of this chapter and knowing the difference between the two. So SN1 reactions are unimolecular nucleophilic substitutions, and this occurs in 2 steps. So the 1 tells you that it's unimolecular, so it's just the one, the molecule. However, it is in 2 steps. So the first step is when the leaving group leaves, forming a carbocation, which is basically just a carbon with a positive charge. And then we have the second step, which is a nucleophile attacks the carbocation, okay? And we can see this down here in this example. So you have SN1 here, we have bromine attached, then the leaving group leaves, okay? So you have Br minus, and this left a positive charge on this carbon, the carbocation, right? And then we have a nucleophile come in and find this positive charge, and now that is what is on this molecule. So that is an SN1 reaction. But we also have an SN2 reaction, which is bimolecular nucleophilic substitution, and it occurs in 1 step. So what happens is there's an inversion in stereochemistry when this happens, because the nucleophile performs a back-sided attack at the same time that the leaving group leaves. So we have down here, we have the nucleophile, we have our molecule with X, this is going to be our leaving group. Then we're going to have an intermediate step where the nucleophile is coming in and the leaving group is leaving at the same time. And then you're going to end up with your leaving group and the new nucleophile attached. But this SN2 reaction prefers less substituted carbons due to steric hindrance. So that means the less substituents that a carbon has, the more likely it is to be an SN2 reaction, right? Because if it was attached to a lot of other things, it would be difficult to have this big intermediate step, right? So, and don't forget there's an inversion of stereochemistry when this happens. You can't necessarily see that in the drawings that I drew, but you would notice that there is a difference in stereochemistry. So our next thing that we're going to talk about are the reaction of alcohols. So we have primary alcohols that can be oxidized to aldehydes with PCC. Okay, so these are just some reagents that you should know as well. Then we also have primary alcohols being able to be oxidized to carboxylic acid, but that would take a much stronger agent, okay? Then we have the secondary alcohols, which can be oxidized to a ketone by any oxidizing agent. And they can also be secondary alcohols can also be converted to mesylates or tosylates, which basically makes this alcohol a better leaving group. So that's just also some important vocab to know when we're talking about alcohols. Then we have the reaction of aldehydes and ketones. So aldehydes can be oxidized to carboxylic acids. Aldehydes can be reduced to primary alcohols using LiAlH4. Then we have ketones that cannot be further oxidized, and they can be reduced to secondary alcohols using the LiAlH4 reagent, okay? So for me, I definitely just needed to, this is something I had to memorize. I looked at a couple of videos before, really grasping the concept of this, but just knowing what these things can be oxidized or reduced to and the reagents that that do those things is important. So I would definitely suggest, memorizing these things. I mean, it does kind of have an order to it. If you're looking at the priority of functional groups, you can see the order that it takes kind of on like a timeline type thing, but it is definitely something I would recommend memorizing. The other thing is you can have aldehydes and ketones that can be protected by acetyls or ketols. So they basically will create a protecting group so that the aldehydes and ketones will not react. But this, like we said, uses acetyls when you'll have your hydrogen in our group. And then here is the ketols, and they have just 2 R groups, right? Both attached to oxygens. So that, again, is just some important basic vocab. Finally, we are in the last portion of this chapter where we're looking at reduction and oxidation. So Leo the lion says GER is one of the few acronyms that you can memorize for this test to know that the loss of electrons is oxidation, and the gain of electrons mean it was reduction. So Leo, lose electrons oxidized, and then GER, gain electrons reduced. So for the oxidation, it can either lose electron or gain a bond to oxygen. Sometimes you can look at that aspect as well to make it more clear of what's being reduced, what's being oxidized. And then for reduction, it can gain electrons or lose a bond to oxygen. So the oxidation number is the charge as if that atom had fully ionic bonds. Then we have our oxidizing agent, which performs, right, which allows the oxidation to take place, but that specific agent is actually getting reduced, right? And then we have a reducing agent, which through this process will actually get oxidized. So it will help the molecule reduce, but the molecule itself will become oxidized, right? Because there needs to be a give or a take of electrons. They have to come from somewhere. So that's what those reagents are for. Then we have polar protic and polar aprotic solvents. And so polar protic solvents basically have an OH or an NH bond. And then the polar aprotic solvents do not. So the polar protic examples are acetic acid, H2O, NH3. And they all have an OH or an NH bond. And then we have polar aprotic solvents, which include DMF, DMSO, acetone, ethyl acetate, for example. And then the last thing down here, just at the bottom, is again just some important vocab. A Lewis acid is an electron acceptor, okay? A Lewis base is an electron donor. A Bronston-Lowry acid is a proton donor, and a Bronston-Lowry base is a proton acceptor. So those, again, are 4 really important vocab words that you'd be able to look at the molecules, and you'd have to identify what one is losing electrons, what one is gaining electrons, and definitely being familiar with the Lewis and Bronston-Lowry theories of both of those things, because they are different. One is looking at electrons, the other one is looking at protons, right? So that's it for this chapter. If you have any questions, please put them below. And if not, we'll see you in the next video.